and neutrons are called fundamental particles. Are called fundamental particles. Okay, first of all, we are going to look at the discovery of electron. Discovery of electron or the cathode ray experiment. Or the cathode ray experiment. Now, what happens in the experiment? Okay, I will show you the experiment and then we are going to move on. Just give me a second, I will show you the experiment. Can you guys see the new screen? There is a disclaimer. Yes or no, bole yaar. Can you guys see the screen? No, you guys can't see the screen.
Next, we're going to look at the properties of a
My voice is lagging. Not lag. How is it now? How is it now?
So better.
Better. Can you see the screen, Alina?
Yes, sir.
electrons as particles and waves. This is called a cathode ray tube. It generates electrons, and when they strike this white screen,
Pause the recording right now. And these negatively charged particles, these are having wave nature as well as the particle nature. Just give me a second. The discovery of electrons by cathode ray experiment. Okay. Now you have seen the experiment. I will also give you a small diagram that you can make. Just give me a second. So this is a basic schematic diagram for the cathode ray experiment. And just take a screenshot, leave some space, then you will write some points. You have already seen what happens. I will just wait 5 more seconds. 5, 4, 3, 2, 1, and 0. Right here, characteristics of cathode ray. Characteristics of cathode ray. They were called cathode rays because they originated from cathode from cathode. Next one. They got deflected in the presence of, please write these things with me, okay? Please write this up. In the presence of magnet. Therefore, we can say that cathode ray has charge. Cathode ray has charge. Next point. Cathode ray travels from cathode, that is from the negative to anode, that is positively charged, meaning cathode ray negatively charged. Positive के पास जा रहा है, it is attracted by the positive. Next point. Cathode ray moved a pin beam. मतलब ये पैंट टाइप का जो देखा था, is placed on its path. Therefore, we can say cathode ray are particles. Are particles. Now, another one of the observations later it was saw that cathode ray travels in speed of light. Raise your hand, one student. Raise your hand once you're done. Alina, am I audible clearly now?
Yes, sir.
Am I
Yes,
audible
sir.
clearly?
Yes, sir. You're audible.
Raise your hand if you're done, guys. I hope you were writing with me. इतना time क्यों लगा रहे हैं? जल्दी जल्दी लिखिए. These guys. Ali and Sajid, please tell me, are you there in the class? Ali, Sajid, and Abu Bakr.
Yes, sir.
What are you writing, Sajid? Are you not done till? Sajid, are you
No,
still
sir.
not done? Why were you not writing with me? What were you doing while I was writing? One more minute, please write quickly. Write this very quickly, yaar. I was writing, you should write with me. Sajid is done. Just waiting for Ali and Abu Bakr. Abu Bakr, you have joined just now. You got this. Ali got disconnected now. Abu Bakr, can you please take a screenshot for this? Characteristics of. No, actually, you got disconnected in between, na? You got disconnected in between. That's good. Yeah. I know you were there in the class. You got disconnected, so please take a screenshot for this. Moving on. Next point. There is one thing that is known as charge by mass. Okay. There is one thing that is known as charge by mass ratio, and we have done the charge by mass ratio calculation for electron. Now, in the previous class, okay, J. Thomson was the one who was doing the scaffolding experiment, by the way. And what we saw that, first of all, he took air, he took hydrogen, he took nitrogen, he took helium, okay, he took oxygen, right? He took. Can all of you guys hear my voice? Alina, Sajid, Abu Bakr, can you hear me? Can you hear me, guys?
Yes, I can hear you.
Okay. Ali, there is some problem. क्या बोले हम? Ali, I can't hear you. What you saying? Others can hear me. Okay. So when he took different gases, what he saw that for all of these gases, the charge to mass ratio was same. Okay, the charge to mass ratio was same. What did this show? This shows that the charge to mass ratio, or we can say that cathode ray, which was formed by all of these different gases, all of these are like the cathode ray, it is independent of what gas you are using. It is going to be same. Right. So next point we are going to write charge by mass ratio of cathode rays was found to be independent of the gas used in discharge field. ठीक है? No. Then you write by the following by the above observation. By the above observation, J.J. Thomson suggested the following atomic model. Suggested the what was the model that he suggested? We have atom. He suggested that it is going to be solid. Okay. And this particular atom, it will be having some negatively charged particles. Some negatively charged particles. Some negatively charged particles. Right? Like this. And he also suggested that the whole atom will be positively charged. I will explain why he suggested this. Don't worry. This whole atom, he suggested, it is positively charged. And inside this, positively charged, it means 10 to band. So this whole atom is positively charged, and inside it there are negatively charged particles embedded. So why did he say that negatively charged particles are embedded? Because the negatively charged particles बाहर निकल जा रहे हैं. ठीक है? How it बाहर कैसे निकल जाते हैं? Because in the cathode ray experiment, we saw that negatively charged particles are coming out. And if anything is coming out, that means it must have been embedded in the system. उसको ऐसे डाला गया होगा. Those will be small particles which are coming out. And he did not find any evidence for a positive charge particles. Okay, he did not find any evidence for the positive charge particles. That is why he said that in order to make the atom neutral, the overall atom will be positive charge. And inside it, there will be negatively charged particles embedded or plugged in. So what he said was, he said atoms are positively charged sphere with negatively charged electrons in it. With negatively charged electrons in it. This model of atom है ना, is aka Coulomb coding model, or in India it is known as watermelon model also. Watermelon model. Can you copy this down? Raise your hand once you're done. We have done the Thomson model, Thomson atomic model. The limitations of this we will write when we are discussing model. Okay, right now we discussed cathode ray experiment, and from the cathode ray experiment, J.J. Thomson was able to give the this model of atom, the Coulomb pudding model. That is why I have just written it here. Okay, please raise your hand once you're done. Raise your hand once you're done. Please try to wait quickly, guys. ज़्यादा time मत लीजिए, please. Very small points. Waiting for Abu Bakr, Alina, and Ali. Waiting for Abu Bakr and Ali. So you have also understood, I hope, that the electrons they were discovered by J.J. Thomson. Next is discovery of proton. Discovery of proton. Please write this with me. I will not do it after writing down. Okay. Please write this with me. Discovered by Goldstein from observations of anode ray experiment. Right? Now you don't have to go into details of this. Next, the only point that you want to write is the charge by mass ratio, Q by M. Charge by mass ratio of anode rays was found to be very less than that of cathode ray. very less than that of cathode. Meaning mass of anode rays was much greater than that of cathode rays. Okay, if this ratio is this, that means mass would have been high. And if the denominator is large, then only the value will be smaller. That is why this now positively charged, because anode rays है तो positively charged होगा. ठीक है, so it is originating from positive and it is ending to negative. ठीक है, so we write mass of proton will be greater than much higher than mass of electron. That is raise your hand also done. जल्दी लिखो भाई, कितना टाइम लगाते हैं आप लोग लिखने में? Waiting for Ali and Sajid. Just wait. अच्छा वो कर तो हो गया ना. Right, next. The charge to mass ratio of anode rays was found to be dependent on the gas used. The gas used, and it was also found charge to mass ratio of hydrogen gas was found to be maximum. Okay. If this ratio is maximum, that means obviously ये जो mass होगा ये बहुत कम होगा. This mass would be lowest. H2 is lightest gas. Okay, if mass will be low, then only this ratio will be high. इसके बाद देखिएगा discovery of neutron. Discovery of neutron. Just two very small points. Discovered by Chadwick. This was very late, as neutrons are not charged particles. it was difficult. Therefore, it was difficult to detect them. Was difficult to detect them. So please down raise your hand once again. Raise your hand once again. Sorry, guys, I got distracted somehow. Is everyone done writing as of recently? Okay, सबका. Wait, is anyone still writing? Anyone still writing? Right, next, models of atom. First, we will write Thomson's model. So, for Thomson model, we have already written what the Thomson model is, right? And how we also got the Thomson model. Now, we will just write the drawbacks of Thomson model. Okay. We are going to just write the drawbacks of Thomson model. First, thank you, right? Drawbacks of Thomson model. Now, there are various drawbacks of Thomson model. One of the main drawbacks. So by the way, drawbacks generally drawbacks are known once we have a better model with us. Okay. So when Thomson gave the model, that was the best model available. Okay. Later on, when other people, for example, Rutherford, when he gave the when he gave his model after the experiment of alpha ray scattering, then in that case, that became the new model, and it then had it then led drawbacks for the okay. Basically, यहाँ पे क्या है? There are few drawbacks. Number one is it is a static model and does not talk about motion of electron in an atom. That is one of the drawbacks. Okay. The another drawback इसमें it does not talk about the nucleus of an atom. It does not talk about nucleus of atom. Another thing that it does not talk about is how the positive charge, it is, how the positive charge is holding the electron inside the atom. Okay. It does not explain how positive charge holds the electron in an atom. Last, reiterate, it does not explain Rutherford's alpha ray scattering experiment. ठीक है, चार काफी लिखा गया. Write this down, raise your hand once you're done. Raise your hand once you're done. Let me know if you're still writing. Second is the Rutherford's experiment or Rutherford model. Okay. So first of all, we'll look at the experiment, and then we are going to look at the observations and conclusions from there. Right. So this is the experimental setup. Don't worry too much about the experimental setup. Like it is so complicated, we have to make this. You don't have to make it. Okay. Basic क्या है यहाँ पे हम आपको कुछ चीजें show करने वाले हैं ना. Just try to focus where I am asking you guys to look at. ठीक है. ठीक है. एक करके देखेंगे. So first of all, where the experiment is starting from? The experiment is starting from here. Okay, let me take a different pen. So the the experiment is starting from here. Here we have something, है ना? You will not know what it is, radioactive substances and everything. You will not seriously know that. There is something which gives us alpha rays. Itna samajh. What is alpha ray? Alpha ray, it is helium nucleus. Helium nucleus का मतलब क्या हुआ? Helium nucleus का मतलब हुआ you will be having helium 2 positive. There are 2 electrons in helium. You remove the 2 electrons, you will get the helium nucleus. Right? So that is alpha ray. अब उसके बाद और आप इसको छोटा ये कर लीजिए. There is a positive charge particle, alpha ray. Alpha rays are what? Alpha rays are positively charged particles. Here we have something which gives out alpha rays. It gives out alpha rays. Okay, and we have put a gold foil. We have put a gold foil in between. So we have put a gold foil in between, and we are having some observation. We are doing some observation. If you think about, give me a second. If you think about the Thomson's model, the atom, it is filled with negatively charged particles. It is filled with negatively charged particles, and overall, it is what? It is overall positive. We have saw that the Thomson model, the atom is overall positive. Now, what will happen if positive strikes on positive? It will repel. So, what Rutherford was expecting is that none of the alpha ray particles are going to go beyond the gold foil, because what happened? Because the complete atom is positively charged, and alpha rays are also positively charged. It will repel it, and it will repel it. But that is not what we saw. What we saw was all the alpha rays, mostly not all, but mostly all the alpha rays, it passed through the gold foil, and just behind the gold foil, we put up a screen and we applied this zinc sulfide, the same zinc sulfide, which when hit by any charged particle, it shines. Okay. So we have a few setup, that is what I'm going to tell you. We have alpha rays, positively charged particles coming. We have gold foil. Just beneath the gold foil, just after gold foil, we have a screen in which we have applied zinc sulfide. And this screen was lighting up because alpha rays are hitting the screen. So this is screen at a spike. It was lighting up, let us suppose you can say 100 times per minute. Okay, just giving you example. Okay, it was lighting up 100 times per minute. Then they went from A to B point. When they went to B point and they kept the screen at the B point, at B point the screen was lighting up, let us suppose 20 times per minute. Okay, the screen was lighting up. That means alpha ray was getting the screen at point B 20 times per minute. Then they went further towards the sea level. At sea level, when they went to sea, let's suppose it was glowing or it was shining 1 time per minute. Now these are the observations. And from these observations, we are going to lead. There will be some conclusions. Now, when I say at A point, I'm getting 100 glows, it is striking up or it is hitting the A point 100 times per minute. That means almost all of the alpha ray particles are passing through the gold foil and hitting the screen. That is my observation. Okay, I'm going to write the 3 observations at the 3 point. At point A, what is happening? We can say most of, because we are getting 100 shines or 100 glows per a minute. Just give me a second, guys. We can say that most of alpha rays pass through gold foil without any reflection. Now, it would mean the alpha rays did not find any barrier while traveling through the gold field. How will they not find any barrier? When there will be vacant space. So what this means, if most of the alpha ray pass through the gold field without any deflection, that meaning most of the atom is vacant space. Most of the atom is vacant space. Vacant space. At B point, what is happening? We are getting some alpha rays, right? Because it is hitting only 20 times, so we can write some alpha rays got deflected. Some alpha rays got deflected from their path. What would this mean? This would mean atoms have positively charged nucleus. Nucleus वगैरह word तो बाद में आया, but what we can understand is that if some alpha rays got deflected from their path, it would be in the center of an atom. Most of the atom is vacant. The center of the atom, there is something which is positively charged. Why positively charged only? Positively charged because it is deflecting the alpha rays. If the alpha rays, if the alpha ray is getting deflected, that means that particle in the center will also be positive, because then only positive and positive are going to repel each other, right? Alpha ray is also positive. The center will also be positive. Then only it is going to get deflected. C part. When we are at C, what is happening at C point? Very few alpha rays bounced back. Very few alpha rays bounce back, meaning nucleus of atom is very small and dense, and tiny and dense and dense. So these are the three observations and these are the three conclusions that we can do. Again, I will give you a very sasta picture that you can easily make. You don't have to worry about the big picture. Raise your hand once you're done writing. You don't need to draw the picture, just take a screenshot, draw and leave some space. Raise your hand once you're done writing. Waiting for Alina and Sajid. Now, we have got various models. Of the next model that is Bohr's model. But in order to understand the Bohr's, like how the Bohr's model came to be, see, most of the observation and the experiment was done only by that cathode ray experiment is there. So that cathode ray experiment, and we were thinking about those waves, or we can say those light particles, lights. Okay, when you have cathode ray, anode ray, and also one more thing, from the Thomson model, we got to know that there are electrons, and from the Rutherford model, we got to know that there is a positively charged nucleus. So the only question remaining was how is the nucleus arranged? So by the way, limitation on the nearly higher Rutherford model. Can this go to the right, the limitation, then we will talk about later on what right limitations of Rutherford's model. ठीक है, लिखिएगा. The Rutherford, we also said that, like we got to know that in the center we are having nucleus, and just because we have the solar system, like there is no evidence why Rutherford suggested that electrons should move in an orbit around the nucleus. Okay. He did not have any evidence. He just said that because similar to the planet movement around in the solar system. And also it is kind of like it's very poetic that the largest thing that we know about, the largest thing that we know of is the solar system. And at that time, we knew many things, but one of the largest thing that we know, it is the solar system, in which in the center we have the sun, and the planets are revolving around the sun in an orbit. It is kind of poetic if I say that atom, which is the smallest thing that we know of, inside that also we are having something in the center, and the electrons are orbiting it, right? So Rutherford said that he did not have any evidence. But if I do calculation, I have a positive charge center, and the electrons, which is negatively charged, is orbiting. Obviously, this positive charge and this negative charge, they will be attracting each other. So with every passing second or every passing minute, the electron will be coming closer to the proton, coming closer to the proton, coming closer to the proton, and it should drop inside the proton. Because positive and negative charge, they are going to attract each other, right? But that really does not happen, because if that happens, then we will not be alive. Atoms, everything is made up of atoms. That is one of its Rutherford's saying. Now, the limitation is, we say, a simple limitation, you accept Rutherford cannot explain, or rather did not explain the stability of atom. Second point you will have. Second point tells us that did not explain the stability of atom. If we consider atoms to be orbiting around nucleus, then electron would lose energy, and finally collapse in the nucleus. Okay, so these two limitations are main basic part है ना, basic part here, what is inside an atom? That we have a proton, we have protons, we have electrons, and we have neutrons. And we also know the region where nucleus is, the region where proton and neutrons are present, that is the nucleus. Proton is also inside the nucleus. Neutrons are also inside the nucleus. Electrons are outside the nucleus, but how the electrons are present, uसी के बारे में सारी कहानी. And we got to know about electrons from the cathode ray experiment. In the cathode ray experiment, we saw that electrons are having some wave nature and some particle nature. Now we have the wave nature of electron, and further studies were done on that wave nature of electron. Okay, further studies were done on the wave nature of electron. In order to study those experiments, in order to study them, the experiment that were done on the wave nature of electron, we will have to first of all understand many things about a wave. And that is why in between you have a big portion that is related to electromagnetic waves. Right? So from models, like you will see Rutherford model, and then you will start seeing waves in the NCERT also, and then you will see Bohr's model. Why? Because in order to understand the Bohr's model and the latter experiment, you have to understand how waves behave, what are the different properties of wave. Okay. And you have to also understand some calculations related to electromagnetic waves. वही heading डालिएगा आपको electromagnetic waves. Electromagnetic waves. For electromagnetic waves, you will first of all draw a picture. Draw this. आराम से properly. Raise your hand once you're done. Raise your hand once you are done. Please raise your hand once you are done. We are not going to go into very much details. छोटा-छोटा definition सब है, definition लिख के जाइएगा please. The first one is known as wavelength. Wavelength, it is denoted by lambda. This is the sign of lambda, and it is known as lambda. LAMBDA. Okay, इसको lambda बोलते हैं. What is this? The distance between two adjacent crests or troughs. Adjacent crests or troughs. Right? Yeah, because one of the crests and adjacent crest is the between distance over that is lambda. It's trough and one trough. So line the end part of the trough बोलते हैं crest to सबसे ऊपर वाला part में. The topmost part of a wave, the lowest most part of the wave is known as trough. The distance between two adjacent trough or crest is known as lambda or wavelength. Now, there are some values, if you remember, that will be very useful. We have P2, okay, which is denoted by P. It is a number whose value is 10 to the power minus 12. Similarly, we have nano, represented as N. It is a number whose value is 10 to the power minus 9. Similarly, we have micro, which is represented by mu, and the value is 10 to the power minus 6. Also, we have milli, hope you know milli, represented by small m, whose value is 10 to the power minus 3. Now, we can use this in order to show the distance, because the distance between the two crests and trough for an electromagnetic radiation will be very less. So, we are going to use these values. So, if I say 1 picometer or 1 pm, this would mean what is pico? 10 to the power minus 12 and meter ke liye meter. If I say 1 nanometer, this will be 10 to the power minus 9 meter ke liye meter. So, okay. So, what I am doing in place of nano, I am writing 10 to the power minus 9. ठीक है ना, उस तरह से सोचिएगा. Please don't think like in order to convert 1 picometer to meter, I have to multiply by 10 to the power minus 12. वैसे मत सोचिएगा. Pico means a number that is 10 to the power minus 12. Rather than writing pico, pico का p नहीं लिख के क्या लिख रहे हैं 10 to the power minus 2. जो value है उसकी हम value को plug in करते हैं. ठीक है ना. So think in these terms, it will help you a lot. And if you have 1 micrometer, that means for micro, what is micro? 10 to the power minus 6. And in place of meter, I will write meter. ठीक है, तो कभी भी आपको ना मल्टीप्लाई करना डिवाइड करना उसका कंफ्यूजन कभी नहीं आएगा. If I have 1 millimeter, I have 1 millimeter, that means it is, what is the value of milli? 10 to the power minus 3 and meter के लिए meter. There's also one special unit used only for distance, like pico, nano, micro, milli. All of these can be used for grams also. It can be used for seconds also. This pico, nano, micro, milli, these are words and they have a value. And there is one special unit that is angstrom. This is only used for distance because it means 10 to the power minus 10 meter. In place of angstrom, what we will write? 10 to the power minus 10 meter. This whole thing means an angstrom. ठीक है, so क्या पढ़ा जाता है? इसको पढ़ा जाता है angstrom. ANGSTROM, है ना, angstrom. Raise your hand once around. Everyone is done. Next important part is frequency. We can see it is represented by this letter which looks like V, but we call it mu. NU mu. Okay, this is, it looks like V, a very stylish type of V, but we call it mu. ऐसे लिखिए, And what is frequency? Please write with me. Number of waves that passes through a given point in 1 second. In 1 second. Okay, that is called as the frequency of wave. Now, number of waves, 5 wave 1 second में पार हो रहा है, 10 wave 1 second में 1000, 5000, lakh, 10 to the power 14 waves are passing in 1 second. Right? So number per second. So number will not have any unit. Per second will be the unit. The unit of this frequency will be second inverse or hertz. HERTZ, which we can write as HZ. इसके बाद देखिएगा थर्ड velocity. Velocity को तो वैसे v से denote किया जाता, but we are going to represent it by c because all the electromagnetic waves, it travels in the speed of light. Okay? So you will write all electromagnetic waves travel in speed of light. Therefore, the value of c will be equal to 3 into 10 to the power 8 meter per second. अगला लिखिएगा. Write the fourth one. Amplitude. Amplitude को small a से denote करते हैं, तो क्या होता है small a. Right? It is the height. It is the height of crest or depth of trough. Depth of trough. Amplitude gives an idea about intensity of wave. Intensity of wave. Fifth is important. Amplitude उतना कभी काम नहीं आएगा in the numericals and everything. This one is important. Wave number. Wave number is given by nu and it has a bar over it. ठीक है? क्या पढ़ते हैं? Nu bar. ठीक है, so this is very important. So definition bit tricky है इसका. Please see the number of wavelength. The number of wavelength. Give me a second, please. The number of wavelengths per centimeter, number of wavelengths per centimeter, and it is equal to the inverse of lambda expressed in centimeter. Okay. So if you want to calculate, so mu bar or wave number will be equal to 1 upon lambda. और ये lambda किसमें होना चाहिए था, सेंटीमीटर में होना चाहिए. But what is the actual meaning? Okay, wait a second, Alina. So देखिए, what is the actual meaning? How much of Alina? Can you please have your mic on and tell me?
Sir, till second question I didn't complete.
ठीक है, just give me a second. इस पे लिख लीजिए पहले, उसके बाद if we explain this part.
Yes, sir, I can see this part.
हाँ, just till second के बाद आपने लिखा है, या second भी नहीं लिखा है आपने?
Sir, second नहीं लिखा.
ठीक है, रुक जाइए, explain कर देते हैं उसके बाद, ठीक है? Just give me a second. ठीक है, प्लीज एक बार वेव नंबर समझ लीजिए, उसके बाद हम आप लोगों को टाइम दे देंगे. सपोज फ्रॉम हियर टू हियर, this distance is 1 centimeter. This whole distance is 1 centimeter. Now, how many wavelengths are we having in between? From here to here, there is one wavelength, 1 lambda, 2 lambda, 3 lambdas. How many lambda? There are 3 lambda in what, in 1 centimeter. ठीक है, so what we can say, यहाँ पे हम क्या कह सकते हैं? We can say that the wave number, it is equal to क्या है? The number of wavelengths per centimeter. Number of wavelengths, how many wavelengths are there? 3 centimeter inverse. So this will be the wavelength. This is the conceptual part. Otherwise आपको जो basically करना पड़ेगा, अब जैसे मान लीजिए what will be the value of lambda, यहाँ पे lambda की वैल्यू क्या होगी? Like this is 1 centimeter. In 1 centimeter we are having 3 lambdas. So the length of each lambda will be 1 upon 3 centimeter. ठीक है, this is what? This is lambda. और mu bar क्या होगा? According to the formula, lambda का inverse क्या हो जाएगा? 3 centimeter inverse. ठीक है, तो conceptual part ये है, like in 1 centimeter how many wavelengths are there, and basically you are going to use this formula only. ठीक है, आपको ये conceptual part सिर्फ समझने के लिए. Okay, now you can write. ऐसा कीजिए ना, you take a screenshot, सारा ही लिख लीजिएगा फिर. Those who are done till wave number, please raise your hand.